Our topic in second quarter for week 1, quadratic inequalities. The city government is planning to construct a new children playground. Wants to fence in a rectangular ground using one of the walls of a building. The length of the new playground is 15 meters long. It is wide and its area is greater than the old playground. So, in the given situation, the width of the room can be represented by width and the length by W plus 15. If we represent the area of the old playground as A, then the quadratic inequality that would represent the given situation is W multiply it by W plus 15 is greater than A, or A squared, W squared plus 15W is greater than A. Suppose the area of the old playground is 2,200 meters squared. What could be the area of the new playground? Then what could be its length and width? Is it possible that the value of width is negative? The situation tells us that the area of the new playground is greater than the area of the old playground. This means that the area of the new playground is greater than 2,200. It could be 2,300, 3,500, 4,600, and so on. One possible pair of dimensions of the new playground is 50 meters and 65 meters, respectively. With this dimension, the area of the new playground is 50 meters. Multiply it by 65 meters. Then the result is we have 3,250 meters squared. It is not possible for W to take a negative value because the situation involves measures of length. So this time, you have to draw a graph of a quadratic inequalities. Then, like for example, find the solution set of y is equal to x squared positive 3x positive 2. Then we have here the table. So we have x, the value of x, negative 5, negative 4, negative 3, negative 2, negative 1, 0, positive 1, and positive 2. So this time, you have to complete the table. Then find the value of y. Then we have here, y is equal to x squared, positive 3x, then we have positive 2. Then we have the value of x is negative 5 squared. Then plus 3, multiply it by negative 5, then we have here plus 2. Okay, so simplify. So we have negative 5. The square of negative 5 is 25. Then negative 5 multiply it by positive 15. The result is negative 15. Then we have positive 2. Then add. Okay, so we have here 25 plus 2. The result is 27. Then minus 15. So y is equal to 27 minus 15. So the result is 12. So, we have here the value of y is equal to positive 12. So, this is now the ordered pair. The ordered pair is negative 5 and positive 12. Then next, okay, so this time, okay, let us solve now the value of y if the value of x is equal to negative 4. So, we have here the equation. So, y is equal to x squared, positive 3x, then we have positive 2. Okay, so we have negative 4 squared, then positive 3, multiply it by negative 4, then we have positive 2. So, the square of negative 4 is positive 16. Then negative 4, multiply it by 3, so we have negative 12, then plus 2. Then add. So, we have 16 plus 2, then minus 12. Okay, so 16 plus 2, that is 18. 18 minus 12, okay, that is 6. Okay, so we have the ordered pair, negative 4 and positive 6. The next time, okay, we have the value of x is equal to 3. Then the equation, x squared positive 3x, then we have positive 2. Then we have the value of x is negative 3 squared, then positive 3, multiply it by negative 3, then positive 2. So, the square of negative 3 is 9. Then we have 3 times negative 3, the result is negative 9. Then we have positive 2. So, we have 9 minus 9, the result is 0. Then we have 2. So, therefore, the value of y is equal to positive 2. Then, the ordered pair, we have negative 3 and positive 2. Okay, so next we have if the value of x is equal to negative 2. So, we have here the equation y is equal to x squared positive 3x, then we have positive 2. So, the value of x is negative 2 squared positive 3, multiply it by negative 2, then we have positive 2. Okay, the square of negative 2 is 4. Then we have multiply negative 2 times 3, so we have negative 6. Then we have positive 2. Then combine. Okay, so we have 4 plus 2, 6. Then minus 6. So therefore, the value of y is equal to 6 minus 6. The result is 0. So we have the ordered pair, negative 2 and 0. The next, so if the value of y is negative 1, then we have the equation y is equal to x squared positive 3x, then we have positive 2. Then simplify. So we have the value of x is negative 1 squared, positive 3, multiply it by negative 1, then we have positive 2. So the square of negative 1 is 1. Then negative 1 times positive 3 is, we have negative 3, then we have positive 2. Then add 1 plus 2, that is 3. Then minus 3, so y is equal to 0. So we have the ordered pair, negative 1 and 0. Then next, if the value of x is 0, then we have the equation y is equal to x squared positive 3x, then we have positive 2. So we have the value of x is 0, we have 0 squared, positive 3, multiply it by 0, then we have positive 2. So the square of 0 is 0. 0 times 3, the result is 0, then we have plus 2. So we have here 0 plus 0 plus 2, so the value of y is equal to 2. So therefore we have the ordered pair is 0 and 2. Then next, so if the value of x is 1, so we have here the equation y is equal to x squared, positive 3x, then we have positive 2. Then simplify. So we have the value of 1 is 1 squared plus 3, multiply it by 1, then we have positive 2. The square of 1 is 1. 1 times 3, we have the result is 3. Then we have plus 2. So add. So y is equal to 1 plus 3 plus 2. The result is 6. So therefore, we have the ordered pair is 1 and 6. Then last, so if the value of x is positive 2, so we have here the equation y is equal to x squared positive 3x, then we have positive 2. Then simplify. So we have if x is 2, then we have 2 squared positive 3, multiply it by 2, then we have positive 2. Then the square of 2 is 4. Then 2 times 3, we have here 6, then plus 2. Then add 4 plus 6 plus 2 is equal to 12. So therefore, the ordered pair is equal to 2 and 12. Then this time, you have to draw a Cartesian coordinate plane. Okay, so this is now the Cartesian coordinate plane. In the Cartesian coordinate plane, we have two lines. Okay, so the horizontal line is the x-axis. And the vertical line is the y-axis. Then we have, okay, let us now draw a graph based on the given table. So we have here, first you have to plot the points. The ordered pair, negative 5 and positive 12. So it is located in the second quadrant. So we have here negative 5. So the y-axis is positive 12. So we have here now the point. In line of the negative 5 and the x-axis, and we have here y-axis. The value y-axis is 12. The next, another ordered pair. We have here negative 4, the x-axis, and the y-axis is positive 6. So you have to plot the point. We have here 6 in line of negative 4, and we have positive 6 in the y-axis. The next, another ordered pair. The x-axis is negative 3, and the y-axis is positive 2. So we have here, the x-axis is negative 3, and the y-axis is positive 2. So we have here the point. The next, if another ordered pair, we have here, the x-axis is negative 2, and the y-axis is 0. So we have here the point. Okay, so we have here another ordered pair. X is negative 1, and y is 0. So the point is here. The next, another ordered pair, we have your x-axis is 0, then the y-axis is 2. So point is here. The next, another ordered pair, the x-axis is 1, and the y-axis is 6. So the point is here. Then the last. Okay, so the x-axis is 2 and the y-axis is 12. So the point is in line of positive 12 and we have here the positive 2 in the y-axis. Then after plotting the point, connect the line. Okay, this is now the line. So this is now the graph of the inequalities. We have the equation that is y is equal to x squared positive 3x and we have positive 2. The form of the graph is a parabola. Our activity in Math 9 in second quarter for week 1. Find the solution set of each of the following quadratic inequalities. Then graph. Write your answer in the yellow pad paper.